Okay friends, welcome back. We will be talking about something called standard template library or STL in this particular module and the next one. What is STL and why it is important is discussed in this particular module, and we will have a look at one of the important container of that STL called vector in this particular module. We will look at others in the other module. STL is basically a short name of standard template library. It is a library containing all templates, function templates, class templates, and is a standard. So, is available under all platforms that you come across, which obviously complies with ANSI C++ standard. So, what is the advantage of using an STL? It is not like some other library, it is something which is very different than conventional libraries. As I said, it contains functions and class templates. The function templates in STL are known as generic algorithms, and the class templates are known as containers. Class templates, the containers here contain multiple objects within, and that is why they are called containers. And those generic algorithms are designed so well that they can work with almost all classes that you come across, and that is the reason why the STL has become so powerful a tool in the deployment of C++ based any computerized system based on C++. So, let us talk about that. Okay, we already have learned about templates and their ability to program with generic types. Generic types, what does that mean? Generic types mean you just specify a type and that type is replaced by the other type which user specifies later. Standard template library or STL is a library of templates, okay, which is provided as a standard available with all compilers who comply with ANSI C++ standard. As I said, class templates, they are known as containers, function templates are algorithms, are generic algorithms. It is not a conventional library, like conventional libraries usually have a hierarchy. For example, a graphics library will have a hierarchy, will contain shapes and different types of shapes and specific member functions for it. So, we will use it for a specific purpose. If I want to generate something related to graphics, okay, I will use that library for that purpose. And usually that library is based on object oriented model. I will define virtual functions and use them for accessing the elements and so on and so forth. STL is not of that type. Okay. STL is very different, this is general. General means you have containers, you have algorithms, they have very little relationship also. Okay. So, they are quite general, and we can add containers, we can add algorithms on our own, and they work on each other. Not only that, they are designed like templates. So, there is no runtime overhead. Okay. So, if you can use STL in your program, you get all the facility without any overhead, and it is not like the libraries, conventional libraries, is very different, and when you will soon be able to understand when we talk about some of the examples. Okay. It uses non-member functions. Say most of the libraries are, their richness derives from their member functions, like we discussed about a virtual function called draw for a graphics library, which is basically a member function, a virtual function, but a member function. And such member functions enrich such library. Okay. More such member functions, better the library is actually. Here the concept is very different. We won't have member functions here, we will have all non-member functions, these are all generic algorithms. Generic in the sense that it can be applied with multiple classes, not only that, well, multiple types, because they are templates. Okay. So, it is a very different, very unique kind of a concept. So, let us first of all talk about containers, the class templates, specific class templates used by STL. Okay. They contain objects of other classes, okay. They themselves contain other objects. There are two different types of containers. One is called sequential container. The sequential container is the one where the objects are stored in the sequential order. Whatever you insert at the end or in the beginning. Sometimes you can add in the beginning also. Sometimes you can only add at the end and not in the beginning. Some containers allowed insertion in the middle also, we will talk about that thing. but normally these sequential containers, you insert that in a typical sequence and that sequence belongs to you as a programmer. Okay. The system does not decide any sequence. In the case of sorted associative container or SA containers, the point is that they are always in sorted order. So, whenever you insert, you do not specify the sequence where the element is to be inserted, the element will be inserted in a sorted order wherever it fits itself. Okay. So, suppose if you have 1, 5, 7, 8 and now you insert 5, 1, 5, 7, 8 and you insert 4, it will insert after 1. Okay. So, it will keeps itself in the sorted order. Okay. How that sorted order is decided and all that we will talk about, but these two are different types of containers. We will be looking at the examples of both of them. Okay. One is called vector, it is very similar to an array, okay. But then this array can be of any type, okay. This vector, not only that, can even be extended unlike array. So, array, if you have defined an array of 10 elements, you cannot insert an 11th element at any point of time. A vector can have an additional element. Okay. So, how that is managed is also quite interesting, but we will talk about that. It can extend itself. Okay. The other one is list, which we are going to look at. List also is very simple data structure. You know, list is basically a doubly linked list. If you have a bit knowledge of data structure, you know there is a doubly linked list which contain two links, one to next element, one to the previous element. Okay. So, you can move in both directions. So, list is implemented internally as a doubly linked list. So, the advantage of this is that you can insert element at any point of time without much of an overhead. An interesting concept in STL is that it is designed, these generic algorithms and containers are designed with one primary goal in mind: performance. They will have to act as fast as they can, okay. And we will see many examples of that during this discussion. And that is basically the idea on which C++ itself is designed. So, STL adds to that, nothing else. Okay. There is something called dequeue. Dequeue is a double ended queue. You can insert from one end, insert from the other end, you can delete from one end and you can delete from the other end. You can provide restrictions like one end is completely restricted, then insertion on one end, deletion from only end, it is basically a stack. Okay. And you just allow insertion from one side and deletion from the other side, it makes it queue. So, dequeue can be adapted to either stack or queue depending on what your need is. Okay. Set is a sorted associative container. So, you can insert elements and those are keys basically. So, you just insert elements and then elements will always be inserted in a sorted order and you can always access them. The advantage of sorted associative container is that internally they are stored in form of height balance trees. If you know bit about height balance trees like AVL and RAID black tree and all that, you probably have the idea about this. The great thing is when you use such a data structure is that insertion will take a bit of time, okay, but then the reference is pretty fast. If you know bit of data structure is O log n to the base 2. Okay. So, it is pretty fast. In simpler terms, in a sequential array, if you have 8 elements, you will have to actually on an average 8 by 2 is what you need. Okay. You will have to check for at least 4 elements to on an average to find an element. If you are using this thing, it becomes 3 elements, okay. And larger it is, it will become lesser. Okay. The amount of memory, amount of searches that you need is much lesser. So, that is the power of it. Okay. Map is the other one where a key and additional element is stored, and again it is sorted on a key and you will be able to access that pretty fast like the set case. There are multi-key versions, multi-set and multi-map, where see normally you only allow one element with one key. If you insert the other element with the same key, the older element is overwritten. So, set and map both, this is the case. If you use multi-set and multi-map, you will be able to do it for multi-key case also. For example, why you need such a case? I will just give you one example for you to understand. Suppose if you are a student and you are learning something and you are storing that information in some database. For example, you are storing information about the project that you do. So, you store two things, your own name and the project that you have done. Now, if you expect to only have one project, set will do, but or map will do. But if you want to have multiple projects on your name, so there is a single key, but then there are multiple records, you need multi-map or multi-set depending on what you want. But when you know that there is always going to be one value, for example, your enrollment detail, there is always going to be one enrollment detail for you, then there is always going to be either set or map depending on how you are going to use it. So, if you have that constraint on key, use set or map. If you do not have that constraint on keys, you expect records with same record with multiple records with same key, you should use the multi version. Okay. As I said, sorted associative containers always insert the element in a sorted order. It will take a little more time, but the reference is pretty fast, very fast. Okay. The other point is that these generic algorithms and this thing, the containers, they are connected with something called an iterator. Iterator is a pointer like object. So, what you do is the generic algorithm will do what? Will use a pick up an iterator and browse through the items of the sorted associative container and do whatever it wants, and they are very similar to pointers. For example, you can define them like a pointer, you can dereference to get the object they are pointing to. Okay. You can pass them to function, you can return that thing from the function, and so on and so forth. So, they act almost the same as the pointers, but they are not pointers for two reasons. In fact, there are two things which differentiate between a pointer and an iterator. The first thing is that the iterators are classified into multiple categories, and that is a very smart move actually, because sometimes some algorithms do not work well with a given data structure. For example, a doubly linked list. So, doubly linked list is very good at insertion and in the middle of it, but is very poor if you want to do it random access. You like to access nth element and then n minus 1th element and then some other element, that random access kind of is not very good at, because you will have to move sequentially in the list. If you pick up a vector or a DQ, you can access them randomly, that is absolutely fine with them, but it is not very good with list. So, how the algorithms are designed? For example, there is an algorithm called sort. It is told, it is specified that the sort will demand a random access iterator, and a container which provides random access iterator can only work with sort. So, if you call the generic algorithm sort with a list object, you will get a compilation error, okay, because this is the power of iterator and the categorization. The second difference is that the iterator is normally implemented as pointer, but you can use some other implementation. I am not here, this is very technical part, so I am not stressing it further, but then there are some references that you can read and learn about this. One good is the Scott Mayer's book, which I specified earlier. Okay. So, you may read, there are a few examples given there, and Stanley Lipman's book also talk about C++ primer also talks about a case where you can implement iterator as something else. Okay. Let us look at a history. There is a guy called Alexander Stepanov who thought of this generic programming having generic components and algorithms, and they just use each other, and he implemented that thing in EDA, and in fact, C++ was nowhere there in his mind when he proposed this generic programming idea. But then later on, when he started working with AT&T, he understood that C++ is a better candidate, and then implemented that thing there and learned that is something that is really great. And there was a guy called Andrew Koenig, who was part of a standardization committee, who thought that this idea is really valuable for the people who are working with C++. He showed Stepanov to the committee, and committee unanimously accepted this idea, and probably as many experts said so, STL is the biggest addition to the NC C++ standard. Okay, let us look at the generic programming principles. Okay, we have two things, generic components and generic algorithms. The components are containers. Okay. Generic algorithm work on components without any premeditation. Please understand, there is no dependency. So, generic algorithms only understand one thing, the iterator. They say that I will need 2 random access iterators. Sort would say that I need 2 random access iterators wherever they are pointing. I will just pick up the elements and sort them, that is all. Okay. So, it says that I only want this random access iterators, nothing else. I am nothing, no relation between this two except this iterator requirement, okay, nothing else. You may query me that sort requires that ordering, but sort will not say what kind of ordering I want, neither the container says that the order that I need a specific order. In fact, it is the object which is inherent, which is there inside the container decides the order. For example, I am storing all employees, okay, or students, for example, is a better example, because I can store students in the order of their roll number, because I want to print their roll call. I may store students in the descending order of that merit, because I want to print a merit list and something like that. So, I may even do it according to their name, because I just wanted all of them to sit in the exam where it is sorted name wise. Point is the object, inherent object which decides the order, neither sort or neither the algorithm nor the container does so. So, that is the design, that is why it is called very generic, it is actually very generic. Okay. So, algorithms designed with minimum dependency on components, only iterators, okay. Requirements are specified only in terms of iterators and nothing else, and most algorithms work with most containers without any change, that is the beauty of this design. And we have already said that it is a templatized design, because it is a templatized design, the type does not make any difference, okay. You can use the same sort, you can use sort with a conventional array, you can use sort with an employee array or employee vector, you can use sort with DQ containing cricketer objects and so on and so forth. So, that is really generic, in true sense it is generic. And there is no runtime overhead. The biggest thing is we will get all these facilities without a single bit of overhead at runtime, which is something C++ always wanted. Not only that, C++ is really good in one thing, there is nothing which is forced on you. If you want, you may use it, if you do not want, you may not use it, and that is the choice available to us as a C++ programmer. Okay. So, okay. Reusability and other attributes. So, the biggest advantage of this algorithm and component is reusability. I can use sort with integers and any other object which is stored either on vector or DQ or whatever, which provides me random access iterators. So, it is very generic, very reusable kind of ready-made components off the shelf. I do not need to define, I just take it from the STL library and use it, and the standard is available on across all platforms. So, I do not need to bother with whether it is available on target, because I may be designing system where it is going to run on the user's machine. I do not need to bother much about, because it is a standard implementation there will always have this components there. Okay. Designed to be used in variety of situations. For example, if I define a queue, queue is an adapted container from DQ, I can use it for customers queue in a restaurant, or I can use that thing in operating system design, storing the process, the information in the process queue and so on and so forth. The other great thing is that they are so generally designed that can be used with myriad of situations and processes, okay. And they are well debugged. Experts have designed, tested and all that, and not only that, a lot of people in the world are actually using it for years, and if there are any issues, probably would have noticed and repaired. See, if you have a choice, your programmer defines his own algorithm and your programmer uses a standard built-in algorithm from STL, obviously you know what to trust more. Obviously, STL is to be trusted more because it is a proven thing. That is the advantage, and it is basically an optimized expert level coding. And as I said, every component, every algorithm is designed with a typical time specification and it is kept. Okay. So, hardly ever you will find a user with that kind of a vision when he does program. So, it is usually better to use an STL component, this is usually better in terms of performance. And services, the other great thing is that the all member functions and all that are so consistently defined. Learning one particular container and algorithm makes life very easy for learning other things. It becomes your learning curve very simple. There is no steep learning curve here. Okay. But okay, that is very interesting point is that there are two different ways you can access your elements in C++. One is called address mechanism, the other one is called functional mechanism. The address mechanism is found when you use a pointer. For example, you define a pointer here and this is an array. Okay. So, you iterate through these elements using this p. Okay. So, you just do it. So, you define p as dummy. So, it starts pointing at this place. It will increment and continue pointing. So, it will actually print 1, 0, 1, 2, 3, 4 and all that. Okay. So, this is an example of address mechanism. You just point there and just change. Okay. Increment p plus plus will point to the next element and star p will give you dereference that pointer and will give you that value. That is called address mechanism, which is very fast because what you need is a few statements to address an element. It is very powerful, you are directly addressing that element, but it is also dangerous in the sense that if you make a mistake. For example, greater than 10 instead of 10, if you write 100, it will start showing lot of junk values on the screen, because that is what it is. Your address, your picking up addresses which are beyond the boundary of an array, nobody C program or C++ program will tell you that you are doing something wrong. You will get all those junk on your screen. And if you are doing it with some real systems, that real system will be flooded with that junk. So, that is, so if you want to prevent, like many languages like Java thought that this is the worst thing available and we should not have it in our language. So, they have eliminated pointers, okay, just to make sure that such things do not happen. But then it is the fastest way you can do it, and many of the top flight programmers would love to do it that way. And that is the reason why it is provided, iterators provided in that fashion by C++. File operation, if you know how to access a file, you won't access file elements by pointers, you will just say get file name .get and .put and so on. So, that is called functional approach, and that hides the underlying complexity, because in case of a file, so many a times you have to move to some other sector and so on and so forth. So, that kind of a movement, that kind of job is simplified actually, because you do not need to worry about that, you just use two functions and those functions manage the complexity. That is simple, easy to use and comparatively safer way of doing it, but then it is not all that fast. C++ is not designed to be simpler, you may do it, okay, it is your choice, but that is not the first. As I said, C++ provide both the choices, but iterators are available directly to you. So, you may use it, okay. The point to contained object can be dereferenced, can be incremented exactly like pointers. Okay. They provide that fine control to the programmer. Okay. For example, assigning one iterator to the other and jumping from one place to the other, and you do it very fast. Like in case of a file, if you want to jump to 10th element, it is not very easy. In case of an iterator, what you can do is you just say that p plus 10 and you jump to 10th element. That is the power of the iterator. And as I said, they are categorized, and because they are categorized, the advantage is that you know that which iterator is going to work for you, and that means the algorithm can determine which kind of a container will be useful for them and which kind of the container cannot be used. Okay. So, that fine control is achieved by this design, and they may be implemented as pointers, but the programmer can think of something else as okay. And the other thing is iterator is open, is available to a programmer, that is the power. Okay. So, programmer can manipulate iterators. Second thing, using addressing mechanism, the job is done in the fastest way. Earlier case, the previous slide, okay, you can see that I will just use the single statement to jump to the next element and print it. I do not need to have multiple statements. Okay. So, that is what is available with us. Okay. Okay. Characteristics of the containers. Containers can grow automatically. Okay. When user continues to insert element, okay, the memory allocation is also automatically done. If there is a need for reallocation, C++ runtime system provides, okay, automatically. You do not need to do it yourself. Well, we will soon see how it is done. Okay. You can copy an object, container object into another, simple, a vector into some other vector, or list into vector, or DQ into vector. You can actually, the content is copied. Okay. New containers, new algorithms, and new parameters. For example, you could devise a new way of allocating memory, it is possible. So, you can do it, if you wish, you can do it. Okay. And we will only look at first sequence container in this particular module called vector. Okay. We can define vector as this, and there is a class called cricketer, which I am going to use. And then I say that we see pushback, which insert the element. So, I am defining a vector is like an array. In the beginning, it will have 0, no element. When I insert one element, it will automatically grow. So, the Mitali is an element which is inserted inside. Okay. And there is an integer vector also, okay, and where I insert 4. So, there is one more element integer where I insert 4. Here I am inserting something called Mitali. Okay. Now, I am defining an iterator. Okay. So, vect int iterator int index, and cricketer iterator will be cricketer index. So, there are two type of iterators, and every iterator is different. Okay. So, depending on the vector and the type, there is a separate iterator. Here vector and the type, we have a separate iterator. There are functions like begin and end, which I can use with all all containers. Begin will always return me the first element in the sequence, end will return me an address of the next element after the last element, okay, one more than the last element. Is kind of end of file mark, if you know a bit about that. Okay. So, and here is a class cricketer. I do not need to talk about that much, it is all normal class, will contain jersey number and name, and there is I am using only a simple constructor, and this is important. I am providing an operator. Why I provide an operator? Remember, I told you that every object that is used in a container should provide the ordering on its own. It is the onus on the designer of that class to provide that, and the operator bool less than actually does so. Here is the operator for displaying the elements. And here I am using push back, so insert at the end. So, I am in this integer vector, I am inserting 1, 2, 6, 9, 4. I am defining cricketer objects Mitali, Sushma, Harman, Dipti, Julan and Veda, and I am inserting them one after the other in the VC vector. Okay. Now, I am defining the iterators for both of them, and then a very simple thing, I will begin with int. Okay, vi dot begin will return me the first element, which is Mitali, it is the earlier case. So, it is a integer value, and until this becomes last but plus 1, I will continue incrementing. It is a conventional C or C++ programming. I am just displaying the integer element. The same logic is applied for displaying the cricketing element, and I have overloaded double less than operator here for the same thing. So, the output is very simple, whatever I have inserted is displayed, and here I have got the cricketer objects being displayed. Okay. And here is the description which I already provided. Extending the vector is also possible, and how it will extend itself is exemplified by the program that we are going to talk about. We have again both vectors defined, a cricketer vector and int vector. Okay. And there is a function called capacity, which we call Vc dot, this is a member function. So, Vc dot capacity will give me the capacity of the vector called Vc, Vi dot capacity gives me the capacity of the vector called Vi. VC is a vector for cricketers and VI is a vector for integers. Okay. So, we have two values, one defines the current capacity, current size for this thing VI, and the other one is for VC. And what I do, I will continue, I have 200 elements, I am just pushing the element, and whenever vector increases, the VI dot capacity becomes different than the size, the earlier size. When that is done, I display both of them, and the same logic is applied to both cases. And here is it shows the integer vector in the beginning, both of them have no element. So, the size is 0, then it increases to 1, 2, 4, 8, 16, 32, 64, 128, 256 and so on, because the last element was 200, it demanded 256. So, you can see how it grows, and the case of VC also it is like this. Okay. And we know that this over operator less than is to be overloaded, and whenever we need to compare two elements, we also need to overload a double equal to operator. Okay. So, with that note we will conclude this particular module. What we have seen in this module, let us recap what we have done. We looked at standard template library, the way to code in a generic fashion. We looked at containers and algorithms are two components, they only have dependency using something called an iterator on each other, and is an excellent solution provided by Alexander Stepanov for using an algorithm with any class, only using that iterator and provide the fastest possible solution to any given problem, because it is designed with optimized view. With that note, we conclude, friends. Thank you all. Thank you all. Thank you all. Thank you all.